This is the plan of a stream, and this is the ordinary flood level in the stream. When it is in floods, the water spreads up to this side and this side, and when a maximum flood occurs, it will spread up to this far on both sides of the stream. And this is the bank level, high bank level, all seen in the plan as we see it from top. That is what's called plan. Now in the case of base flows, there will be only small flow in the main course of the stream, in the bed of the stream, and it will be of a magnitude of 1 or 2 cusecs, as we said again. It could be even more than that in the case of a bigger stream. So the diversion of that spring flow can be done through a rubble stone structure without using cement, described here, and the water level rises slightly by about a foot, and then the water is diverted through a canal on the right side, and it is also possible to take another canal on the left side, or limited to only one canal depending upon where the command area is available. This canal is a gravity flow canal, and the area in between the canal and the stream can be irrigated by a gravity flow. This is not a pumped scheme or any such thing. It's a low cost gravity flow. It can irrigate about 10 acres of land on either side, could be 20 acres, and if the discharge is bigger, it could irrigate even something like 20 acres here and 20 acres there. So this is done at a very low cost. The structure itself is costing only about 4,000 rupees, and this is similar to the one which the tribal farmers construct for the hill streams. Now let us study this in greater detail. In the section, it is something like this. This is the bed of the stream, and when ordinary flood comes, it flows like this up to this, and then there is a small drop because this is the structure which elevates the water level, and down below this will be the flow line. And if a maximum flood occurs during very heavy rains, the flood level will be something like this. During base flows, that is during the spring flows, when there are no floods, during the non-rainy period, there would be still some water in the stream. So let us say this is the base flow water level, and if it is more than that, it overflows over this. Now this is a simple rubble stone structure, dry stone rubble, stone rubble with a toe wall here, and the purpose of this is to see that the base flow doesn't flow down. If supposing the structure is not there, then the spring flow flows down. Now when the structure is built, that is conserved, and that is diverted through an open gravity flow canal on either side. We will now go through the technical details of this structure. This is the plan of the structure and the stream, and this is the cross section of the structure and the longitudinal section of the stream, and this is the cross section of the stream. Let us first go through the plan. This is the stream course having a width of W. So the stream is flowing like this, and across the stream a structure like this is constructed with rubble stone without the usage of sand or cement, and this structure would appear like this in the cross section of the structure. This is the bed level of the stream, and just above the bed level these rubble stones are dumped and packed as shown here. The flow is in this direction, and when maximum flood occurs, this would be the maximum flood level, and it flows like this, creating a hydraulic jump and dissipating the energy. The obstruction is very small. As we see here, it is only 0.6 meter height. We do not require a very high obstruction because it is enough if 0.5 meter depth of water is diverted into the canals. The canals are going to be either 0.3 meter depth or 0.4 meter depth or 0.5 meter depth. So, this structure of 0.6 meter height would be able to divert a canal depth of 0.5 meters. And this is the bank level. As seen in the cross section, this is the left bank, this is the right bank. The stream may be having a slope like this and a bed width and then a slope like this. Here we are going to introduce a rubble stone check with top level here, and this structure is keyed into the side slope as shown here for a distance of 0.3 meter. It does not end with the stream, it is keyed into the slope on the left side as well as on the right side. So, the structure is having a length L. With reference to this length, we can work out to the various quantities of work involved, and for this purpose ready reckoner tables with the dimensions, quantities and cost are given. Now, let us go into greater detail with regard to the structure. When an obstruction like this is there in the stream course, eventually it gets silted up to the top of the structure. So, therefore, there will not be a possibility to draw water when the whole thing gets silted up, because the drawal of water to the canals is through a left side pipe sluice and a right side sluice pipe, which again joins the which is again taken off through a open excavated small canal. Like that, there will be a canal on the left side also, and the operation of this sluice is manual. This can be closed by putting a plank and then opened by removing the plank. This opening and closing can be done during the lean season period, when a person can enter here and can physically close this because the flow is very small. During the flood period, there won't be a need for drawing water from the stream because it would be raining in any case in the Ayacut area also. So, therefore, irrigation requirement is not there, and it is required only when the flood subsides and when small flows occur, then only the sluice will have to be opened. Now, we discussed about the siltation. If it is silted up to this, the sluice also will get blocked. So, we have to clear the silt deposited on the upstream side. A method of removing the silt, what we call scouring or ejection of silt, can be achieved by placing two scour pipes, one pipe here, another pipe here, and in the section it will be something like this, one pipe at this level, and this pipe will be about 0.3 meter higher than the bed, and when this is kept open, this silt here will get flushed out. So, therefore, the upstream portion of the structure will be free of silt when once we operate the scour vent, what we call it as scour pipe. And this scour pipe has got to be kept open throughout the flood period when the floods occur like this. And when the floods subside and the water level comes to the crest of the obstruction, then this scour pipe will have to be closed. The scour pipe otherwise will be taking away the base flows, will be taking away the spring flows. So, during the non-flood period, this scour pipe has got to be closed. As seen from the plan, it has to be closed here, it has to be closed here. It can be closed through a small plank physically. Anyway, during the floods, it is to be kept open, and so it is just removal of the plank, which the farmers can do. In this structure, you would be noticing a small gravel core. This is intended to see that eventually this portion of the structure would get filled up with silt and coarse material, and this functions as an obstruction for flow. This gravel core will encourage the siltation on this side and create virtually an obstruction of flow. That is the purpose of this gravel core. The gravel core also can be seen here, a small dimension of 0.3 meter width, and this is the gravel core. When a structure of this type is constructed in the stream, it is possible to divert base flows of 2 cusecs or 3 cusecs into the canal on the right side as well as on the left side. Now, what is the cost of such a structure? This cost is around rupees 4,000, including the cost of the pipes. So, with 4,000 rupees, we can irrigate about 10 or 15 acres on either side, which means about nearly 20 to 30 acres of land we can irrigate through a simple structure of costing about 4,000 rupees. This is possible because we are creating a base flow, we are making a spring flow available on the stream through several watershed development works on the upstream side. When those are executed, the spring flows are caused, and these spring flows can be economically diverted. The basis for this type of structure is essentially our native knowledge. The tribal farmers in the coastal areas, in the tribal areas, they have this ingenious device built on their own efforts, without the government help or any financial aid. With their own efforts, they build such structures across the streams coming in the forest areas, in the tribal lands. In that case, what they used to do is to have a small structure like this, without apron and all that. Such a small structure may be having a length of about 50 meters or 20 meters or whatever it is, depending upon the bed width of the stream. And whenever a flood of this dimension occurs, this gets breached because it is not well designed hydraulically. A small rubble stone structure like this would breach when a high flood comes. So, every time a breach occurs, the tribal farmers used to restore the breach, and they used to contribute their voluntary labor for bringing the stones from outside or the washed away stones to be collected back, and then they used to close the breach. Now, to avoid such breaches, a small technical intervention is needed. That is, instead of constructing like this, we have a lengthy apron which is stable enough under the flood flow conditions, and also provide for a tow. So, the engineering interventions of the modern technology is to have an apron, sloping apron, and a rock tow. As an addition to the tribal technology, if this is done, then such a structure would be stable even under the maximum flow conditions. It will not get breached. For any reason of downstream scour at a later date, if any damage occurs to the structure, this can easily be repaired by the farmers. The total cost of the entire thing is only 4,000 rupees, and the repair cost would be within their means. So, by means of such a simple structure across the main stream, it is possible to irrigate lands by gravity flow canal without even resorting to pumping.